LISUN is leader in lighting and electrical test instruments. Hello everyone, this is Daisy. Let me introduce to you the installation and use of the LSG-6000 Type-C Moving Mirror Moving Detector Goniophotometer. The following is the video content. Chapter 1. Preparation. Chapter 2. Installation. 2.1. Assemble the cabinet. 2.2. Assemble the goniophotometer. 2.3. Assemble the FAR detector. Chapter 3. Adjustment. 3.1. Adjust the goniophotometer. 3.2. Adjust the FAR detector and the mirror. 3.3. Adjust the near detectors. Chapter 4. Calibration. 4.1. Calibrate the FAR photo detector. 4.2. Calibrate the near photo detector. 4.3. Calibrate the spectroradiometer. Chapter 5. Measurement. 5.1. C gamma test. 5.2. Color distribution test. 5.3. B beta test. 5.4. Save and print the test report. Chapter 1. Preparation. Please unpack all of the wooden packages and put the parts in the darkroom right position. Refer to the darkroom drawing. Please don't throw away the wooden boxes. Please prepare the following tools. 1. One PC with English Windows OS with at least 2 black USB 2.0 ports. 2. One impact drill. 3. One set of hammer. 4. A set of screwdrivers. 5. A set of hexagonal screwdrivers. 6. One 12-inch adjustable wrench with 36 mm opening. 7. One electric forklift which can lift 2 tons up to 1.6 meters. And the length of its furcated feet must be over 1.200 meters and width over 0.6 meters. 8. Hydraulic forklift with capacity of 2 tons. Chapter 2. Installation. Please confirm that your darkroom is built exactly according to our drawing. Assemble the cabinet. There is a wiring diagram on the door of the cabinet. Put the corresponding equipment into the cabinet and connect the wires according to the wiring diagram. The terminals here is connected with the power strip inside of the cabinet. It is used to power all the equipment inside of the darkroom. Then you can control the power of the whole system on the cabinet. The grounding terminal is important and please use a wire to connect to the ground. Assemble the goniophotometer. There is the software in the CD. Please install the software and the driver to the computer. And install the APK in your Android phone. Put the base of the goniophotometer to the correct position according to the darkroom drawing. The arrow indicates the direction of the FAR detector. Remove the front panel. There are 4 big screws to fix the base with the beams. Install the light arm. Remove the screws and put this cover down. Remove the 6 screws here. Separate the cable as the figure. Those 2 cables to the left and the rest 2 cables to the right. Lift the light arm by a forklift. Put the cables through the left and right holes and install the light arm. Fix and tighten the 6 screws back. Connect all these cables to the terminal bar according to the colors and labels. Insert the temperature sensor to the left port. Remove these screws that are fixed to the wooden case. Use a forklift to lift part A onto part B. Please note that the equipment is heavy. Handle it carefully. Please note that the direction of the light arm is the direction of the FAR detector and it is also the direction of the red arrow. Fix and tighten all the screws. Make sure all 4 big screws touch the ground. Connect the wires for the goniophotometer according to the wiring diagram. The grounding terminal is also very important. Please use a wire to connect it to the ground. Turn on the goniofotometer. This is the main axis. The end with some wires is for the near detectors. The end with no wires is for the mirror. We install the mirror holder first. Open the app. Turn on the Bluetooth of the phone. Click to connect the device. Enter a number here and click rotation buttons. Try to rotate the main axis to the position shown above. If you want to use the software to operate, double-click the software icon. Then you see configuration if the first time you run the software. Choose all the models of your system and click Auto Search Communicate. You can choose Not Installed for detectors and colorimeters. After all the installation, you can come back and choose what you have in your system. Click OK. Then you see this window. Choose a path and input a file name. All the test histories will be saved in this file. Then you can use the software normally. Make sure it shows C gamma angles here. If not, click here to change. Then you click Rotary Control Panel. Choose Illuminometer for far field. Then you rotate the main arm here. Install the mirror holder as the figure. Fix and tighten all the screws. Install this part. It is for the near detectors. Rotate the main axis to this position. Use a forklift to lift this part as the figure. Insert the wires through the holes. And fix all the screws. Connect all the wires according to the labels here. The communication cable is for spectroradiometer. Do the connections as shown in the figure. Install the near detector. There are two photo detectors. F is the far detector. N is the near detector. Install the near detector and connect the cables as shown in the figure. Here are the optical fiber connections. Install the mirror. Please note that when you move the mirror, put your hands on the metal frame but don't on the mirror. If on the mirror, you may break it. Rotate the main axis to this position. Lift the mirror and put it on the mirror holder. Make sure the 3 screws on the mirror align with the 3 screw holes. Lock the 3 sets of screws as shown in the figure. Assemble the far detector. Put the rack for the far detector at the correct position according to the darkroom drawing. We use many ties to fix the wires before delivery. You can remove the ties now. Then you can pull out the wires connection box of the goniofotometer and remove its cover. Here are the wires connections of the far detector. This is the power cord. This one goes to the goniofotometer according to the wiring diagram. The port 3 communication cable goes to the communication box inside of the cabinet according to the wiring diagram. There are still 3 wires left. They need to be connected to the wires connection box of the goniofotometer. Put them through the bottom of the goniofotometer. And then go through this hole. Then go to the correct positions of the connection box. Remove the cover of the far detector. Install the far detector as shown in the figure and connect the wires. Chapter 3. Adjustment. Adjust the goniofotometer. Don't install this round plate for now. We need to install it after the adjustment. Connect the power cord for the goniofotometer. Turn on the switch for the laser in the center of the goniofotometer. The laser will go to the wall of the other end of the darkroom. Rotate the big mirror to the horizontal position. There are 2 big screws on the side of the goniofotometer. These 2 big screws are used to fix the light arm. 2 or 3 people hold the light arm steady while another people loosens those 2 screws. Then the light arm can be rotated 180 degrees clockwise. Please hold it steady and rotate slowly and carefully. Then the laser will draw a semicircle. If the radius is small, it can be ignored. If the radius is large, adjust these 4 screws to move the laser to the center. You can double check that the laser spot is a point, not a circle when the light arm rotates. Then rotate the light arm to the original position and tighten these 2 screws firmly. Fine-tuning the position of the goniofotometer. And adjust the 4 big screws. Make sure that the laser goes to the center of the last partition. There is a switch on the top of the light arm. Turn it on. Then you can see another laser comes from the top of the light arm. There is another cross laser device. Take it out. Put the switch to unlock position to turn on the cross laser. Turn on both of the horizontal and vertical lasers. Adjust the position and direction of the cross laser. Make sure that the laser at the center of the gonio-photometer always coincides with the center line of the cross laser. Fine-tune the 4 screws of the gonio-photometer again to make sure that this laser from the top of the light arm also always coincides with the vertical laser of the cross laser. You may need to fine-tune the cross laser together with the gonio-photometer. Then the final location of the gonio-photometer is determined. Lock the big screws. Adjust the FAR detector and the mirror. Find this small mirror. It should be in the standard lamp box. You can remove the FAR detector for now. And install the mirror to this hole. Adjust the position and direction of the rack of the FAR detector. Make sure that the laser from the center of the gonio-photometer goes to the center of the mirror tool, and the reflected laser goes back to the original position. Then fix the rack to the ground with screws. Make sure that the direction of the rack is still okay after fixing it. Install the FAR detector back. And install the mirror on the FAR detector. Open rotary actuator control panel. Select illuminometer for FAR field. Input 0 here. Check with synchro axis. Then click to rotate the gamma angle and the FAR detector both back to 0° position. Then you need to adjust the screws of the mirror. And also adjust the direction and height of the FAR detector. Make sure that the laser from the top of the light arm goes to the big mirror and goes to the mirror tool on the FAR detector. And the reflected laser from the mirror tool of the FAR detector goes back to its original position. All the screws should be tightened firmly after the adjustment. Then you can remove the mirror tool. Install the sleeve back to the FAR detector. And install all the covers back. The FAR detector adjustment finished. Adjust the near detectors. Choose illuminometer for near field and rotate it to 0° position. Then the near photo detector goes to 0° position. Install the mirror tool on the near detector. Adjust it the same way as the FAR detector. Make sure that the laser from the top of the light arm goes to the mirror tool and the reflected laser goes back to its original position. All the screws need to be tightened after the adjustment. Then you can remove the mirror tool and install the detector sleeve back. If your model is LSG-6000 CCD, then you also have a spectroradiometer in the system. And there will be the optical fiber holder here. You also need to adjust the direction. Install that small mirror tool here. Choose colorimeter for near field and rotate it to 0° position. Then the optical fiber holder goes to 0° position. Do the same adjustment as you did for the near photo detector. The laser from the top of the light arm can be turned off now. Put the cross laser back to the position to coincide with the spot laser of the center of the gonio-photometer. Keep the cross laser stable and don't move it. There is another small cross laser device. Remove this laser. And install that small cross laser the same position. And turn it on. Adjust the direction of this cross laser. Make sure that the center of the cross laser always coincident with the other cross laser. Then you can turn off this cross laser device and put it away. After all the adjustment, install this round plate to the center of the first partition. Clean and tidy the darkroom. You can cover the equipment during the cleaning to prevent dust from entering the equipment. Chapter 4. Calibration. Calibrate the FAR photo detector. This is the standard lamp and the extension rod. Assemble the standard lamp holder. Install the small mirror tool here. Install the extension rod together with the standard lamp to the light arm of the gonio-photometer. Be careful not to break the lamp. There is a latch to lock the rod. And the screw handle to tighten the rod. Do the connections here refer to the diagram. This connection method is not only for the standard lamp but also for the samples in future. Make sure the C angle is at 0° position. Adjust the height of the standard lamp. Also adjust the direction of the standard lamp. Make sure the cross laser goes to the center of the mirror tool and the reflected horizontal laser and vertical laser coincident with the original horizontal and vertical laser. After the adjustment, turn off the cross laser and remove the mirror tool. All our standard lamps are constant current DC lamps. Turn this switch to DC. The other switch can always at outside position and no need to change. Choose DC power supply. Input the reference voltage and the rated current according to the certification. Choose CC mode. And click to turn on the standard lamp. The standard lamp needs about 15 minutes to get stable. Then we calibrate the system. Rotate C angle to 90-degree position. Choose illuminometer for far field. Check with synchro axis. Rotate gamma angle to 90-degree position. The synchro axis, far detector, will rotate together with the mirror. The light of the standard lamp goes through the hole of the lamp holder to the mirror, and then to the far detector. Then you need to close the door of the darkroom. Click here to calibrate the far photo detector. Choose far field. We use candela calibration. Input the rated candela according to the certification. Click start. The test distance will change automatically according to your darkroom. Click apply. Click OK. Calibrate the near photo detector. Choose illuminometer for near field. Rotate the gamma angle to 90-degree position. Then the light of the standard lamp will go through the hole of the lamp holder and goes to the near detector directly. Click here again to calibrate the near photo detector. Choose near field. Calibrate the near detector the same way as far detector. Calibrate the spectroradiometer. Select colorimeter for near field. Rotate the gamma angle to 90-degree position. Then the light of the standard lamp will go through the hole of the lamp holder and goes to the optical fiber directly. Click colorimeter calibration to perform spectrum calibration. Select colorimeter for near field. Always check auto for the integration time. Click sample. Then you can see the corresponding curve after the sampling is successful. Enter the correct color temperature value according to the standard lamp certification. Click calibrate. Then you will see the corresponding curve after successful calibration. Click OK to save and exit. Turn off the standard lamp from software after calibration. The standard lamp can be very hot after use. Put the standard lamp back to the box when it cooled down. Chapter 5. Measurement. Car lights and traffic signal lights need to be tested by A alpha. Flood lights need to be tested by B beta. All the other lights need to be tested by C gamma. LSG-6000 can do C gamma and B beta test. C gamma test. LISUN provides 2 clamps for C gamma test. The big cross clamp is for big luminaires. The E27 holder is for bulbs. Install the clamp and sample as shown in the figure. The luminous interface of the lamp should be in the center of the clamp. Need to lock and tighten the rod of the clamp the same way as you install the standard lamp holder. Also need to adjust the up and down of the light arm. Make sure the luminous interface is at the same height with the horizontal laser. Turn the AC/DC switch to the correct position according to the sample. Keep this switch always at outside position. Choose the correct power source. Input the electrical parameters and turn on the sample. Click Setup to set the preheating parameters. Check Warm Up if you need to preheat the sample before measurement. Click to enter the test settings. Choose luminaire type. Indoor and roadway is C gamma test. Choose unsymmetrical if no special requirements. C range is from 0 to 180 and no need to change. Set C step angle according to different samples. If the sample is symmetric in theory, you can use bigger step angles such as 30, 45. If the sample is not symmetric, you need to use smaller step angles such as 10, 15. The smaller the step angle, the higher the accuracy. but the longer the time you need. 2 options for G angle range. -180 to 180 is for samples with lighting angles bigger than 180 degrees. -90 to 90 is for smaller lighting angle samples. Always choose one for G step angle. Select the detector. In most cases, you need to use the far field photo detector. You only need to use the near field photo detector for samples with very weak light. Select the test speed. Usually just use normal. Monitoring point when preheating. No need to change. Check by maximum or by average. If not, the IES file can't be opened by some other software. If you want to remove the stray light, check this option and input the angle. The data beyond this angle will be 0. Input the number of the light sources and the rated lumen of the light source. If you don't know, just keep it blank. Input the luminous size. Input the information of the sample. Input the temperature and humidity of the darkroom. Click OK to enter the preheating interface or test interface. Color distribution test. After the C-gamma photometric test is completed, you can click here to perform the color distribution test. In order to save time when doing the color distribution test, the C and gamma angle intervals can be used with a slightly larger interval angle as shown in the figure. No other settings need to be modified. Click Start to test. B-beta test. Click to change the angle to B-beta. Click Rotary Control Panel. Choose the correct photo detector you need. In most cases, you need to use the far field detector. And rotate both B and beta angles to 0 degree position. This is the B-beta clamp. Install it as shown in the figure. Make sure that the clamp plane is perpendicular to the goniphotometer. Install the sample to the clamp. The luminous interface of the sample faces the mirror. To ensure that the luminous surface is installed in a central position, you need to rotate the beta angle 90 degrees and refer to the cross laser. Choose flood. Then it changed to B-beta test automatically. Select -90 to 90 for both ranges of B and beta angles. The principle of the step angle of B is similar with the step angle of C. And the principle of the step angle of beta is similar with the step angle of gamma. All the other settings are the same with C-gamma test. There is no standard that asked you to do color distribution test for B-beta. So you can't do color distribution test after B-beta test. Save and print the test report. Click Save As. The report can be saved as many formats. You can also print the report to PDF.